Alright, hi, welcome. Today we'll be talking about extrema on an interval. Okay, and there's going to be several types, local max, local min, global max, global min, critical points, all that stuff. And there's going to be a lot of definitions working out there, but how do we actually do that? So what you're going to do first is, once again, find the derivative. This is always helpful when working with this stuff. So the derivative, this is a subtraction, so this is going to be negative sine of 2x. This is going to be chain rule as well. Okay. It's going to be minus 2 cosine of x. Okay. So that one's going to be pretty simple, straightforward. Just working it that way. Okay, now if we set it up, critical points are going to be pretty much happening at 0 when the actual h is 0. So we have it all set up, so we get we simplify the right side as well. So negative 2 sine of 2x, whoops, 2x minus 2 sine of x, or 2 cosine of x. What am I doing? I'm looking back a little bit too far. Okay, so we have it all set up like this. Alright, now both sides can be divided by negative 2, so might as well do it. So y equals sine of 2x minus cosine of x. Okay, now if you notice, I have a double angle, so I'm going to use the double angle identity here, and that's going to equal 2 sine of x times cosine of x. The good thing is we've already done our working out. Oh, and this should be positive. I forgot to make that positive when I factored out the negative 2. My bad. Let's go back there. Let's not get too crazy. Okay, plus cosine of x. Okay, now if you notice, the whole point of doing that was to actually get to where both of these had terms of cosine of x, so I could factor it out. Okay, so now I have 0 equals cosine of x times 2 sine of x plus 1. Okay, now if you notice, I can use the fundamental theorem of algebra in that I have two things being multiplied to give me 0. Okay, so I'd set it up as cosine of x equals 0, and 2 sine of x minus 1 or plus 1 equals 0 as well. Okay, so I solve each, and x is going to be 3 pi halves. Okay, right here. And then I solve this one, and it should be sine of x equals negative 1/2. Okay, and that means that x is going to be 7 pi 6, comma 11 pi 6. There we go. Okay, so thus the zeros are right there. Okay, and because the derivative is defined for all input numbers, this is a complete list of the critical points. So these are my critical points that I'll be looking at. Okay, what are they? Don't know. You could tell by looking at the graph, but to be honest, we got to try to practice this by hand because we're in AP Calc. Okay. Okay, so what we're going to do is take each one of these values and plug it into the original equation. Okay, so we're going to take both of these and we're going to plug it in for this x and this x, and same thing here as well. Okay, and get our values. So when we do h of 7 pi 6, we should get about 1.5. Well, not about, we should get 1.5 when we plug in 3 pi halves I should get 1. I'm not going to bore you with the details of how I got those, so you know, just make sure you take your time with it. And 11 pi 6, I should get also 1.5. So if you look at these numbers, 2 of these are higher than the other. Okay, so what these are telling me, these are global maxes. Well, global maxes, we don't know just yet, but these are definitely maximums on this interval. Whether or not this is a minimum, we don't know until we actually look at the entire interval. Okay, so in order to check the interval, especially in order to check the endpoints of the interval, we just plug those in. So we go h, and we plug in pi halves. Okay, and that should simplify down to -3. Okay, which definitely makes that not a global max. All right, and then we take 2 pi, and we plug it in, and we should actually get 1. Okay, which if you notice, that matches up right there. Okay, so what does that mean for these two? That means that these two are maxes. Okay, this one's a minimum. Okay, and these are just turning points, and we'll learn more about those a little bit later. Okay, so the most important thing we probably need to do is take a look at the actual graph. Okay, so hold on one sec. Okay, and so when we graph it on the graphing calculator, you have to remember the interval has to look like this. You have to set it up like this. Now, if we wanted a closed interval, we would put equals on these two symbols. And we do have to put our function in parentheses just to make sure it's not there. Okay, so if you notice, these are points of inflection. So this is really kind of cool. And as you can see, it doesn't appear on here. Okay. Although it probably should, because I should have had these. Oh, I screwed up. Oh, well. Let's put this back, boom, and boom. Oops. Cool. Okay, so now we can have all of our points of inflection. So if I take a look at this right here, from pi to pi halves, okay, as you can see, it appears at 1 and everything. Alright, so as I can see just by looking at this, these two are definitely going to be global maxes on this interval, and this right down here, pi halves, is definitely going to be a global minimum. Okay? Alright, so I can check it out and just see what's going on. Now what's also happening at these curves is the tangent line is actually going to be 0. 0, 0, 0, 0, 0. Okay, so that's really interesting in itself that it's going to turn out to be 0. And if you think about it, when you do the derivative, if we go back to our derivative and take a look at it, the derivative is showing the slope. So if we set up this, normally we would set this up and the height would be 0, and it's like, oh, that makes sense. But when we do the derivative and then set this equals 0, we're saying the rate of change is 0. And so that explains why we all of a sudden get something different, and that's explaining why we get these lines right here. Okay? Right? And so that's extrema points. Just make sure you do the derivative. You plug in 0 to find all the points that are points of interest or extrema points, and then just work your way down the line by plugging in the points that are within the boundaries. Okay? Alright, and as long as you guys pay attention to that, that should make your job a whole lot easier, and it should make it a lot nicer on this interval to actually find the points of extrema. Okay? Thank you very much and have a great day. Bye.